All right, so we just talked about the vertical movement, going up or down, looking at the C. So now we're going to go ahead and move into our the middle one, the horizontal changes, the moving back and forth from left to right. Now, before we move into the actual portion of that and actually talk about B and everything, on a number line, you would normally see, okay, this is a positive number here, the positive number is on this side, negative numbers are on this side. And you would think, okay, if it's a positive number, we'll move left. If it's negative, we'll move right. But something different happens when it comes to B because it's inside, like inside parentheses. It can be inside the radical, inside the greatest integer function, inside. As long as it's inside, it would do something. So here, it's going to move left or right. But because it's inside, it's going to go opposite of what you think. Opposite of what you think. So here, what normally would say, okay, if it was negative, it would go to the right, it would go to the left. Now negative goes to the left, the right. If it's a positive, normally you would say it goes to the right, but actually now it's going to go to the left. So here, as I just said, if it's negative, if B is negative, that means the function is going to move to the right. If it's positive, it's going to move to the left. And just so you can kind of understand like why that happens, let's say again, we're going to solve for x. And let's say we're using that part that's inside the parentheses, x plus b. If we're looking at that part here and we're solving it for x, that means we would have to drop the parentheses for 1. But then we would subtract both sides, b from both sides. And we get x equals a negative b. So it changed the sign of it. So instead of you actually going with the positive b, we actually have x equals negative b. So when it comes to your inside portion here, because you're solving for x, it's going to go opposite of what you think. Opposite. So if it's positive, it goes to the left. If it's negative, it goes to the right. Okay? So let's go to example 2 where we actually are going to talk about the b portion of it. So we're going to be using our parent graph of the square root of x to sketch the graph of each function. So f of x equals the square root of x plus 2. Okay, so first off, with this, we're going to go ahead and do the graph. So if you need to stop it and actually write the question down and then actually do the graph, do that, stop it first, and then we're going to come on and continue working on this problem. So again, go back. If you need to, go back and do that. I'm going to bring it back up so you can kind of stop it there really quickly. I'm going to lock this in place so it doesn't move. Lock in place so it won't move there. All right, and then here, go and pause it, and then go and do your graph. All right, so you actually wrote down the question, you wrote down the graph itself. So let's go ahead and take a look at it. We know we're talking about a square root function right here, because that's what they gave us originally. And we know from our parent graphs that we just covered, a square root function looks like this. And we're going to do a dotted line for it because, again, this is going to show us that it's the parent graph and not the actual transform function. The transform function is going to be a solid dot or solid line. All right, so with this, let's do red. Let's do purple. We said right here it's on the inside of it. It's not on the outside. It's not the back. And just to give you an idea here, it is not this, where the 2 is on the back side of it. It's not that. It is underneath that radical. So that's what we're dealing with. It's just underneath it. That means we're going to go opposite of what we think. We said normally if it's positive, we normally go right, but we're going to think opposite. So it means we're going to go left. All right, so let's go left here. Let's go left. Sorry. Left 2. So it means we're going to move every single point on this graph over a 2. But again, we're dealing with the parent function here, so we're not dealing with something that's perfection, like done perfectly. All we're going to do is we're going to move it over 2 spots. So it's originally here, so we're going to over 1, 2. And so here, that's it. That's your parent function. That's parent function that's transformed. So the red one is the parent function. The purple one is the transform function. And guys, that's it. That's all you have to do. So the inside changes it, move back and forth. The back goes up and down. So we're going to come to example 3, and we're going to put them both together now. Let's put them both together. So here for example 3, we're going to graph y equals x minus 2 quantity squared minus 3. And with this again, as we're going through it, we have to know what our parent function is for 1, and then we have to know what our transformations are 2, and then we put them together and use them. So with this, I'm going to pull my graph out again. I think I went 4 in all directions again. I believe I did. Oh, did 3 in the bottom, but it's okay. I'm going to lock this in place so it doesn't move around like it happens in the past. Lock in place, lock in place. All right, so if we look at this, we should know what the parent function is automatically. We should know what that is because we wrote down all the parent functions. So we did f of x equals blah for each one of our parent functions. So if that's what we did, that means we need to go ahead and figure out, okay, of those f of x equals blah, which one is this blah? Which one is this blah? And we should be able to tell from our exponent what function we're dealing with. We should. So if we look at it, we should be able to tell that this is x squared, the quadratic function. If it's quadratic, we're going to do a parent function that looks like this. And again, we're not looking for perfection when it comes to drawing these out. The whole thing is showing that we are making the transformations. The biggest portion is, again, is really at the origin, that point there, that we can move it correctly and we can do any type of transformations that needs to happen to the graph. Shrinking it, expanding it, move it up, down, left, right, all that stuff. Okay, so with this, we know it's quadratic because of this squared right there. It looks like the quadratic function. All right, and then we look at our transformations. We have the c that's in the back, that moves it up or down. And then we have the -2 that's on the inside that moves it left or right. So with it, as you guys are studying and going back through this, you should remember that the back one goes up or down, and if it's negative, it goes down. So we're going to go down 3. And then on the inside, the b portion, it goes opposite of what you think. So if it's negative, you originally would say, okay, it's going left. But we go opposite of that, so it means we should be going to the right 2. So here, when we take this function, we're going to move it down 3 and to the right 2. So let's do that. Let's go down 3. So 1, 2, 3. So we take this part here, move it down 1, 2, 3, and then move it over to the right 2. So down 3 and go to the right 2. So 1, 2. So we put a dot right there. That's where the new spot's going to be. All right, there's no other transformations happening, so we just go ahead and draw out the function. And again, what the transform function will be a solid dot, a solid line. Solid line. And that's it. That's putting both b and c together and then being done. That's all it is.